Hey guys, so I'm switching up the video tonight since we were having a little bit of issues with the properties today in class. So this is the homework you have to do for your WSQ tonight. Just watch the video with me. Your summary will be to make sure that you do the same examples that I've done. You can circle them or put a little star next to them. And then any questions you might still have will be your Q portion. Along with that, the questions you need to solve will be the rest of the page, the ones we don't do together. So these first few that you have are actually pretty basic. These fit the multiplication property that you see. That should be the first column, actually the left column on your notes from today. So we have the same base, and when we're multiplying values that have the same base, we keep the base the same and we add the exponents. So we have a 3 and an 8. 3 plus 8 is 11. That's as far as I expect you to simplify. I do not need you to multiply 5 out 11 times. The idea here is just to simplify, not necessarily to get a full value. Okay? I'm going to actually jump down below to number 3. So remember what I was saying in class today. When you have a negative exponent, the exponent has to go into the basement to change. If it's already in the basement, if I saw it in a fraction form, then I would bring it back upstairs. But a whole number is like a fraction, but the value's in the numerator. So we're going to bring it down to the basement in this case. And when we bring it down into the basement, we change the attitude, or change the negative to the positive, and place it over 1. Again, in this case, this is simplified, but I know that you all know what 4 squared is. It's 16, so keep that. We never change the value of the base as far as positive or negative. We only change the sign or the value of the exponent. Okay? Remember, I'm all about that base, no changing. Exponent does get switched. We don't want to deal with negatives. All right, coming over to the other side here, this is the same as number 1, so I know that you could do that on your own. The one thing I want to remind you, if these are my exponents, adding a negative is the same as subtraction. So even though it's showing plus sign, think of it as -2. I know that it's a lot easier for us to subtract 2 than it is to add a negative sometimes. Okay? Here is a division property one, so that is the middle of your note sheet. Again, we have the same base, so we want to keep that base. And then we have 3 and 2, so subtract 3 minus 2, that's 1, 2 to the first power. Remember the example I gave you in class, that if you're 13 years old, you wouldn't say you're 13 to the first power, even though that is to the first power. So actually for this, it would be better to write it just as 2. It means the same as to the first power, we just typically don't put that 1 as an exponent. Okay? All right, let me scroll down to some that are a little trickier for you to try out. So here's the ones that were closer to the bottom of your page. These are the ones that kind of separate the boys and girls from the men and the women, if you know what I mean. So these all fit into that category for the very bottom strip on your notes. It was a strip, and there were 2 lines. First you do this, second you do this. And the first one we always do is multiplication. So as I look at all of these problems, I notice that they all have multiplication of bases that are the same with exponents, and then they all have division, which is signified by that fraction line. So let's try a couple out and see what we can do. Number 7, all the same base. We're dealing with 3's in all of them. So I'm going to only focus on the multiplication portion first, and that means adding the exponents. So I have -4 plus 7. -4 plus 7 is the same as to the third power. Now I'm going to consider the division portion. When I see division of the same bases, I'm thinking subtraction. There we go again. We have to the first power. Do I need to write that? No, I can leave it as 3. This one kind of kicks it up a notch because we are actually, can you even see the problem I have up here? You may not be able to see my problem. Better? There we go. For this one, we have multiplication both in the numerator and denominator, but my step one says multiplication first, so I'm still going to do that. Same base, p, 10 plus a negative 6, adding a negative is the same as subtraction, and I know that 10 minus 6 is 4. Negative 2 plus 8, you can even flip it around if you want to say 8 plus negative 2, adding a negative is the same as subtraction. So now I have p to the 4th divided by p to the 6th. Division, let's subtract them. So p is still my base. I want to make sure I'm still on the screen here for you guys. Yeah, there you go. 4 minus 6. Well, if I have 4, I can't give away 6. So I know my answer is going to be negative. Change it to plus a negative 6. So I have negative 2. Now most of us would stop here and say this is it, I'm done. But remember, we don't want to leave anything with a negative exponent. So what do? Put him in the basement till he changes his attitude. Keep the base the same. We're just changing the exponent. So it's 1 over p squared would be our best answer here. Is this answer correct? Yes, but it's not in the best form. This one is. So that should help you figure out most of the problems that you're going to see tonight. Make sure you have these examples circled. Do the rest of them. See you guys tomorrow.